I think we're looking at a really lengthy question that is high wording. That's 5 marks here for question 5, second part. This part here, this 5-mark question, in summary, this 5-mark question is going to be based on a comparison between metallic and ionic compound structure. So let's dive into things. So to give you a little bit of context here, they help you understand that you are trying to compare between sodium and sodium oxide. And the only physical property that they're giving you is the melting point. So take note, this is our physical property. And physical property is always linked to the type of bonding and within the substance, okay? So here, you need to be very clear that sodium here is a metal, and sodium oxide here is an ionic compound. So we have got 2 different categories of things that you need to compare. So based on your answers, they make it very clear, your answers should refer to the structure of sodium and sodium oxide. So that's 1 mark, okay? Maybe I just label it 1 mark, 2 marks, and then the forces between the particles. So again, sodium, 1 more mark here for forces, and then another mark for sodium hydroxide. So all along, you should have 4 marks if you follow these examples. And then the 5th mark here, because it's a 5-mark question, the 5th mark here is when you compare, okay? So before things get too overwhelming, we can break it down one at a time. We can focus on one substance. So in this case, I've decided to focus on sodium oxide first because most of the students are really familiar with ionic compounds. So I'm starting with ionic compound, my sodium oxide here. Okay, so sodium oxide is an ionic compound, make it very clear. And what exactly is the structure of ionic compound? Because they want you to focus on structures, isn't it? So you need to be able to describe the structure of ionic compound, and that is giant ionic lattice structure. So you can imagine I've got my sodium and my oxide ions, and there are so many of them that they form a structure that looks like this. And this is what we meant by lattice structure. Okay, you've got the orange dot there is our sodium ions, and our blue dot there over there is our oxide ions. And together they create this huge lattice. Okay, so this is what we meant by giant lattice structure. That alone will get you 1 mark. Okay, and then we want to move on to talk about the forces in sodium oxide. So what are the forces over here? So for an ionic compound, it is made up of strong electrostatic forces of attraction between the oppositely charged ion. So what exactly is this oppositely charged ion? It is actually our Na plus and our O2 minus. So if you find that this is a bit too lengthy for you to write, you can just simply say between Na plus and O2 minus ions. That's also fine. So that alone, you will have covered all grounds for sodium oxide. Then we look into sodium. So sodium here is our metal. So we're going to focus on sodium. Again, we're going to talk about structure as well as forces. So for sodium, it's over here. So sodium is a metal with giant metallic lattice structure. And what giant metallic lattice structure look like is over here. Okay, what we have, the plus, this plus here are our positive cation. So in this case, it will be our sodium cation, and this E minus here is our C of delocalized electrons. The word delocalized basically means these electrons they don't really belong to anybody, they just float around the entire surface, on the surface of this metal. Okay, so this is how we describe the structure of sodium. And then we need to move on to talk about the forces of sodium. Okay, so what is sodium made out of? Sodium is a metal, so there is electrostatic attraction between the delocalized electron, which is all the purple color E, and the positive cation. So the 4th point here is to talk about the forces of sodium. So 3rd and 4th point is on Na, and then the 1st and 2nd point is on sodium oxide. And finally, you need to make a comparison because they have given you the melting point, and you need to discuss why these 2 substances have such a difference in the melting point. The main reason is this, because we actually need more energy to break the bond in sodium oxide than in sodium metal. Now take note, this bond here that we're referring to is electrostatic forces. Okay, so I prefer to use the word break. Now, what is the most common? So if you can pause for a while and talk about common error, okay, that students tend to make over here, is when they use the word intermolecular forces of attraction. Now, this intermolecular forces of attraction can only be used on simple covalent molecules, like our water, got water, carbon dioxide, oxygen gas, hydrogen gas, etc. Okay, so be clear on the keywords when you are describing the structures, because the keywords are usually the one that is going to cost you a lot of marks for a comparison question like this. So what are the topics that you need to be very clear of in order to get your 5 marks here? You need to be able to compare between ionic, simple covalent, giant covalent, that's where the diamonds and the silicon dioxide are in, and that is 2024 question, as well as our metallic bonding. Okay, so here is just a 5-mark question to compare between metal and ionic compound. What do you think is going to come out this year for 2026? Do you think it would be simple versus giant covalent? Let me know what your prediction is. And if it's all good here and you find that there's clarity in this video, please like and subscribe and share with a friend who might need this. See you in the next one.